Hi everyone, welcome to Telco Tech Talk. We will be discussing spectral efficiency today. There will be a series of these videos where we'll be having a short videos on how we create our understanding on spectral efficiency. So don't worry about the what I'm probably if you miss a line or so, I'll be attaching the notes of what I'm explaining. So if we just focus on what I'm trying to say, later you can download and probably you can share across. You can for the notes what I'm explaining. You will get this. So don't need not to worry about. Just listen and try to focus on what I'm trying to convey here. So this video will have a scope where we will discussing about spectral efficiency, why it is important, why we need to learn about this, why all AI companies are having use cases around this, how an operators are getting benefited. All these things we will try to touch upon. How it is actually, impacting the real world applications, and do we really need this? Okay. And at the last video of this series, we will have the calculation about spectral efficiency, how we calculate, what are the theoretical values. So just be rest assured, you can directly jump to that video, but I'll prefer to have some basic concepts first here, and then you go to the calculation of spectral efficiency. So what is spectral efficiency? There are so many theoretical definitions around it. Data rate per hertz, BPS per hertz. So you see all this is, but why? Why BPS was not no, let alone important? Why we cannot live with BPS only? What was the problem in that? Why is all this required? So spectral efficiency is critical in terms when how efficiently we use our bandwidth. With every operator having a limited spectrum, okay, especially in countries like India, where there is a fight for every megahertz. There is a close overlapping, not overlapping interference. There is a side-to-side band, right? So how that is where the spectral efficiency comes into picture, where you try to efficiently utilize each and every each and every hertz of your channel bandwidth that you have. So spectral efficiency is data rate per hertz. Data rate is bits per second, or what you call Mbps, 10 Mbps speed, 5 Mbps speed. So that 5 MB, which means 5 Mbps of data is being transmitted per second. So now, how much of that 5 Mbps is being transmitted per? How much of that is transmitted per hertz is what defines the spectral efficiency. So this also kills the question which we have, or the confusion where what is the difference between data rate and the spectral efficiency. Data rate is essentially bits per second, and spectral efficiency is how many bits per second per hertz. So what is the importance of SE? Yes, it is highly important. When you say you can, it allows you to send more data. It allows you to send more data on a same bandwidth, channel bandwidth. That means probably whatever I was capturing, how much area, users, subscribers that as an operator I was catering to, I can improve on that without investing much on the spectrum. And it can have better coverage. I can have more number of users. I will have more ROI. Probably I can translate that back to, for the benefit of users only. So it has a very good importance. And going forward, we will discuss that how actually the use cases of where we are implementing better, we are trying to achieve better SE to have more context and better probably to help our lives in a very layman, I would say. So factors which are influencing spectral efficiencies are, you know, uh, this includes modulation scheme, this includes error correction techniques, signal to noise ratio, OFDM modulation, all these things we will not discuss here. This is not part of the scope. Probably we'll discuss the details of these things maybe in some other video. But as scope here today, we will, okay, we understand that the tech modulation scheme, MIMO, all these are critical factor, and adding to that probably lowers SNR, beamforming in 5G will help to increase the spectral efficiency. While talking of 4G, we primarily know that it works on MIMO. It uses OFDM, orthogonal frequency division multiplexing. We should be knowing about that as a 4G engineer, as a telco engineer, okay, and also about the MIMOs. These two are improving my spectral efficiency, have no essentially helping me to have better efficient, more utilization of my available bandwidth. And with this, I'm reaching to on an average 1.5 to 2.5 bps. Okay, and probably some will argue no, this could be higher. Yes, theoretically it can be much higher. It can be double of that, up to 5 bps or even 6 bps. But considering the environmental factors, considering the sonar, we come close to this range. Okay. And similarly in 5G, we raise it to probably double this in 5G in a normal circumstances, but theoretically in 5G it can go up to 30 bps. So we will discuss maybe in some in the at the last of this series how that is calculated, how much, what is the meaning of 5 bps, 2 bps, 30 bps, how we are achieving that. Okay, what is the formula to calculate that? So don't worry about that. Today we are trying to I'm just trying to explain what I understand from the spectral efficiency. Probably it can help you also. So 5G, it is better than 4G spectral efficiency because we have massive MIMO here, we have beamforming, we have higher quadrature modulation schemes. So all these lead to much higher spectral efficiency, and on an average 3 to 5 bps. On a theoretical, it can go to 15 to 30, 30 being highest for now. So 5G is much better spectral efficiency. Probably you can have, in case you want to if utilize your spectrum, which is probably in countries like India, it comes at very high cost. So you can get benefit of these, uh, you know, technology to efficiently increase your spectral efficiency. Now, it's not a comparison, but the understanding that yes, 5G is much better than 4G in terms of spectral efficiency because of the modulation scheme, because of the massive MIMO beamforming, as we said, as we discussed. But spectral efficiency, again, when we discuss as the importance or conclusion of that, it helps to improve the IoT devices as well. How many IoT devices I can have connected in the same amount of without increasing my bandwidth. So so this is not a closing statement. Okay, this is just for your reference that I hope you should be starting to get something on spectral efficiency. Now, in next video, we will discuss what all are the where or let's say where all spectral efficiency is you know is in use, which all application where all the fields where spectral efficiency is used other than mobile network. Yes, there are fields other than telcos, which are where we equally require spectral efficiency to be higher, and especially in the world where we have OTTs, where we have satellite communication, where we have autonomous vehicle, all this we will discuss. So stay tuned part to the part 2 of the video, and we'll see you.